Welcome everyone to the second part of the first lecture, the one where we are supposed to discuss the complete information case. As you recall from last time, we have discussed so far the hypothesis of the principal-agent model. We have seen some feature. We have seen, for example, that the principal would like to maximize his utility function under V1, meaning the agent exerting E equal to 1 rather than V0, which is a utility that he gets when the agent exerts E equal to 0. Now, the problem that the principal has, as we anticipated last week, is to find an incentive feasible contract which induces a positive effort and ensures the agent participation. The two elements, in fact, that the principal must ensure is that, as we have seen in the timeline, first of all, is that the agents need to accept the contract. And the second is, once he has already decided to accept, is that the agent exerts E equal to 1. These are the two crucial elements. So how does the principal achieve and satisfies these two conditions? First of all, he must ensure that the agent is willing to accept the contract. What does that mean? It means that the expected reward that the agent is going to achieve minus the cost of effort that he has to achieve, that he has to perform to undertake the task, should be none smaller than whatever reservation utility it might have. Let's read again this sentence. Whenever I accept a contract as an agent, I'm going to receive a certain transfer, right? This is what my utility depends on, relies on. So for this to be worth, so for me deciding that it's worth signing the contract, it means that whatever transfer on average am I going to get, as we know the average depends on the effort level that I'm going to undertake, minus the cost of effort that I'm going to exert to perform my task, should be none smaller than a certain reservation utility that we usually normalize with 0, which means that whatever do I get as an average minus the cost of effort, so we can call this as a net utility, should be non-negative. In this case, and in this case only, the agent will be willing to participate. Now, the reason why we calculate the utility of the agent weighting by pi 1 and pi naught, and not pi naught, is that we know that the principal would like him to exert the high level of effort. So this would be the highest possible cost in terms of effort that he might need to exert. So we calculate the worthiness of this contract based on the highest possible effort that he's going to exert. This equation that we have written here is called individual rationality, constraint. Sometimes we can writing like this, or also like participation, constraint. And ensures that the agent, as we saw in the timeline previously, the agent is going to accept the contract. The other element that we need to, that the principal needs to satisfy is that once he knows that the contract has been accepted, that the agent will exert the highest level of effort. How do we ensure that? The way in which we ensure that is to offer a contract such that the expected utility that the agent received minus the cost of effort, so always the net utility, when he exerts the high level of effort, is not going to be smaller than the one he received when he exerts the low level of effort. This can be written in here. We call this incentive compatibility constraint, or ICC. And basically, in this constraint, if satisfied, provides the principal with the knowledge that if I offer the right contract with the right incentive, the agent is going to exert the high level of effort. And why is that? Because the net utility that he received minus the cost of effort when he exerts the high level of effort, E equal to 1, is actually none smaller than the one that he received when he exerts the low level of effort. And of course, there's no effort here because the effort in this case is 0, so we do not have to subtract any cost in here. If this is the case, and this constraint is satisfied, then we know that not only the agent will accept the contract, but he also will exert the high level of effort. Okay? Now that we have all the ingredients, we can proceed by analyzing the case of complete information. And we start understanding also how this model works. So we said before what complete information means. Complete information means that the agent and the principal share the same amount and type of information. Everyone knows everything. There's no hidden action in this case. Remember the example that we did last week. The idea is that whenever the agent exerts the task or performs the tasks that the principal has asked to him, the principal is there, sitting next to him and observing exactly everything that he can do. The reason why we use first and we analyze first this complete information is not because we think it's a real case, it's something that we can see actually in reality, but because it provides us with a benchmark case. So every distortion, every failure that we're going to see when we will analyze the case of incomplete information should be matched and compared with the results obtained in the case of complete information. So in this case, everything is observable and verifiable. First of all, we need to consider that the principal wants to maximize his utility. Okay, so we write down a standard maximization problem. How does he maximize his utility? Basically, identifying which is the optimal T upper bar and T lower bar that he should offer to the agent. Remember that T upper bar and T lower bar, which is the reward schedule, represent our enforceable contract. Okay, so what was the utility function of the agent, of the principal that we saw before? Do you remember? So we can write down pi 1 S upper bar, which is a shorter for S of Q upper bar, minus T upper bar, plus 1 minus pi 1 S lower bar, which is a shorter for S of Q lower bar, minus T lower bar. Now, this utility function must be maximized subject to one constraint only. Now, if you think about what we were saying before, if I know for sure that I can verify the effort of the agent as a principal, I know that the agent has no incentive to cheat. Why? Because I can see him. I can perfectly see what he's doing. So the agent, since there is no asymmetries in information, doesn't have incentive to cheat. If you think about the example studying that that I mentioned to you before with a student, it's like that I can sit with you every day from now till the day of exam and see exactly how many hours you devote to the preparation for this exam. In the end, I will provide you with a mark that, in some sense, we can say should reflect exactly your preparation, because I know exactly how much effort you have been putting for this exam, right? So imagine this is exactly the same situation for the agent. So in some sense, point 2 is already satisfied, right? So if this is the case, we don't need constraint 2, right? Because this has been already satisfied. What do we need instead? We do need to verify case 1. So we need to verify that the agent accepts my offer as a principal, right? So that is willing to work for me, which is this constraint here. So the only constraint that I need to consider in the case of symmetric information, perfectly symmetric information, is that the agent is willing to work for me, is willing to accept my offer. When does that happen? This happens only when I know that the offer that I've done to him is actually better than his reservation utility, better than 0 in this case. So if this is the case, he will be willing to work for me. How do I maximize this utility function? We can construct the Lagrangian function, and so we can rewrite the objective function first, plus lambda and the constraint, which is represented by the utility function of the agent. This is something that I would like to mention and to draw your attention on. When you maximize your utility to find, for example, the optimal amount of wood that you have to buy, provided you have about a certain budget constraint, your utility here is maximized under the budget constraint to find this quantity, this amount. Now, the constraint here, as you can see, is represented by the utility function of the agent. So the constraint, the limit to the utility function of the principal is represented by the utility function of the agent. And this is about the conflict of interest that we discussed at the very beginning of our lecture. So this is where you can see that the two guys have opposite interests. You see again the T positively affecting here, the T negatively affecting here, and at the same time the cost of effort negatively affecting here, but in some sense entering positively here, because it's going to make a better performance. So in this way, you can see that is like the principal agent and the contract theory approach that has to problem and relationship is like a game. It's like a game theoretic approach where the utility of the other agents you are interacting with represents your constraint. Okay, so you can choose whatever T upper bar and T lower bar you want, as far as that will make the agent accept your offer. Going back to the detail, now we can derive our Lagrangian function with respect to T lower bar and with respect to T upper bar, one at a time. And so we can get here minus pi 1 plus lambda pi 1 u prime of T upper bar equal to 0. And then we will get lambda pi 1 divided by pi 1 u prime T upper bar. And then, so we will get lambda equal to u prime T upper bar, which should be greater than, strictly greater than 0. And then we will have minus 1 minus pi 1 plus lambda 1 minus pi 1 u prime T lower bar equal to 0, which will give me 1 minus pi 1 divided by 1 minus pi 1 u prime T lower bar, and will give me this strictly positive as well. Now, since the two expressions are equal to lambda, it means that they're both equal to each other. So we can say that if this is the case, if they have same marginal utility, that implies that T upper bar is equal to T lower bar. This is equal to T star. We call this contract the full insurance case. What does that mean, this result? Think about the where did we start? If you remember, we said that in the case of complete information, there's no need for the principal to verify to induce actually the agent to exert a high level of effort. Why? Because there is perfect monitoring and verifiability of the level of effort. Therefore, the agent has no incentive to cheat whatsoever, and he will exert E equal to 1. But if this is the case, whatever outcome you're going to get, I'm going to offer you the same contract. You are fully insured. Why? Because I know that whatever negative result you're going to get is going to be given by luck, which could be theta upper bar or theta lower bar. And this is what is going to make Q lower bar and Q upper bar. Why? Because I know that the effort exerted was high. So I don't need to exert effort. I don't need to provide incentive for effort. Since I can verify the guy will not cheat, therefore, what I can offer is the full insurance case. So the situation where whatever outcome you will get, Q upper bar or Q lower bar, you're going to obtain the same T. T upper bar equal to T lower bar equal to T star. And we call this the full insurance case. In this case, everyone knows everything. Why do we call it insurance? Insurance against what? Insurance against the bad luck. Think about the example that we did before. The guy that worked on a field for a long time, then comes a flood, and there is no yield at the end of the season. Bad luck. How do I get insured against the bad luck? The principal will say, look, if I can stay with you and see and observe exactly all the effort that you've been putting, all the work that you have been doing so far, whatever outcome you will get, I will give you T. Okay? Because I know that you have exerted that effort, so you deserve a good payment. You deserve insurance against the bad luck. In the next video, we will see what happened when there is asymmetry in information. So when the level of effort exerted by the agent cannot be verified. Now, in this case, I can anticipate you that not only we need to verify one, the individual rationality constraint or participation constraint PC, but we also have to include the incentive compatibility constraint. So the number of constraints increase.